Article 314.28 addresses the size requirements for pole and junction boxes, conduit bodies, and hand-hole enclosures. This section is crucial for ensuring adequate space for conductors within electrical enclosures. Specifically, 314.28 dictates that the size of the enclosure must be sufficient to provide a minimum clearance of at least 6 times the trade diameter of the largest raceway, conduit, or cable entering or leaving the box. In simpler terms, imagine a scenario where a 6-inch conduit enters a sheet metal gutter. According to 314.28, the gutter needs to be large enough to provide a minimum clearance of 6 inches between the conductors inside the gutter and any surface of the gutter. To calculate the minimum gutter size required in this case, one must add the diameter of the conduit to the minimum required clearance. Since the conduit is 6 inches, the calculation becomes 6 inches conduit diameter plus 6 inches minimum clearance, which equals 12 inches. Therefore, the minimum required gutter size would be 12 inches. This means that an 8 by 8 inch gutter, as described, would not meet the NEC requirements because it does not provide the necessary 12-inch clearance. Now let's consider the voltage aspect raised in the query. The reference made was to 300.20, which pertains to ampacity derating for conductors grouped together in a raceway. However, 300.2 does not specify voltage limitations for gutters. The primary focus of 300.2 and its subsections is on the ampacity of conductors, which is the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. When multiple conductors are bundled together in a raceway, such as a conduit or a gutter, their ability to dissipate heat is reduced. This leads to a higher operating temperature for the conductors. To prevent the conductors from overheating and potentially causing insulation damage or fire hazards, the NEC requires that the ampacity of the conductors be derated, meaning it must be reduced. The derating factors are specified in tables provided in the NEC, and they depend on the number of current-carrying conductors in the raceway, as well as the ambient temperature. However, 300.2 does not impose any direct voltage limitations on the use of gutters or raceways. The voltage rating of the conductors themselves must be appropriate for the system voltage, but this is a separate consideration from the ampacity derating requirements outlined in 300.2. Therefore, the statement that 300.2 makes the installation non-compliant due to voltage considerations is incorrect. The non-compliance stems from the gutter size not meeting the minimum clearance requirement specified in 314.28. In conclusion, the initial assessment of the situation is accurate. The contractor has not complied with NEC Articles 314 and 376 due to the insufficient gutter size. The 8 by 8 inch gutter does not meet the minimum 12-inch requirement dictated by 314.28 when a 6-inch conduit is involved. However, the reference to 300.2 as a basis for voltage non-compliance is not applicable in this case. 300.2 deals with ampacity derating, not voltage limitations. For clarity, let's recap the key points. Firstly, the NEC mandates specific clearances for conductors within electrical enclosures to ensure safety and prevent overheating. Secondly, 314.28 provides the rules for determining the minimum size of enclosures based on the size of the entering or exiting raceways, conduits, or cables. Thirdly, in the case of a 6-inch conduit entering a gutter, the minimum gutter size must be 12 inches to comply with the NEC. Fourthly, 300.2 addresses ampacity derating for conductors bundled together, not voltage limitations. Fifthly, the contractor's installation is non-compliant due to the undersized gutter, not due to any violation of voltage requirements under 300.2. To further elaborate on the significance of these code requirements, it is important to understand the underlying safety concerns they address. The insufficient clearance within electrical enclosures can lead to several potential problems. One significant risk is overheating of conductors. When conductors are packed too closely together, their ability to dissipate heat is reduced, leading to a rise in temperature. Excessive heat can degrade the insulation of the conductors, causing it to become brittle and crack. This can expose the bare conductors, creating a risk of short circuits, ground faults, and electrical fires. Another concern is the potential for physical damage to conductors during installation or maintenance. If the enclosure is too small, it can be difficult to maneuver the conductors without bending or stressing them excessively. This can lead to damage to the insulation or even breakage of the conductors themselves. Additionally, inadequate clearance can make it difficult to perform maintenance or repairs on the electrical system. If there is not enough room to work, it can be challenging to access the conductors, connections, or devices within the enclosure. This can increase the risk of accidental contact with live parts, leading to electric shock. The NEC requirements for enclosure sizing are designed to mitigate these risks by ensuring that there is sufficient space for conductors to be properly installed, maintained, and cooled. By adhering to these requirements, electrical contractors can help to create safer and more reliable electrical systems. Now, let's consider some practical examples of how these code requirements apply in real-world situations. Imagine a scenario where a large number of conductors need to be routed through a pull box. If the pull box is too small, the conductors may be tightly packed together, making it difficult to properly terminate them. This can lead to loose connections, which can cause overheating, voltage drops, and even arcing. By using a larger pull box that provides adequate space for the conductors, the electrician can ensure that the connections are secure and that the conductors are properly cooled. Another example is a situation where multiple conduits enter a junction box. If the junction box is not large enough to accommodate the conduits and the conductors within them, it can be difficult to properly seal the conduits to prevent moisture from entering the box. This can lead to corrosion of the conductors and connections, which can cause electrical failures. By using a larger junction box that provides adequate space for the conduits and conductors, the electrician can ensure that the conduits are properly sealed and that the electrical connections are protected from moisture. In addition to the specific requirements of 314.28 ohm, there are other factors that can influence the size of electrical enclosures. These factors include the number of conductors, the size of the conductors, the type of insulation, the ambient temperature, and the presence of any heat-generating devices within the enclosure. The NEC provides guidance on how to account for these factors when determining the appropriate size of an electrical enclosure. It is important to consult the NEC and other relevant standards to ensure that all applicable requirements are met. Furthermore, it's important to note that while the NEC provides minimum requirements for enclosure sizing, it is often prudent to use enclosures that are larger than the minimum size. This can provide additional space for future expansion or modifications to the electrical system. It can also make it easier to perform maintenance and repairs. Using larger enclosures can also improve the overall reliability of the electrical system by providing better ventilation and reducing the risk of overheating. In summary, the NEC requirements for electrical enclosure sizing are essential for ensuring the safety and reliability of electrical systems. By understanding these requirements and applying them correctly, electrical contractors can help to prevent electrical hazards and create safer environments. Remember to always consult the latest edition of the NEC and other relevant standards to ensure that all applicable requirements are met. Considering the specific voltage of 12.47 kV amps mentioned in the original query, it's important to emphasize that while 300.2 doesn't directly address voltage limitations, the overall installation must still comply with all applicable NEC requirements for that voltage level. This includes proper conductor insulation ratings, clearances, and other safety measures. The fact that the system operates at 12.47 kV amps highlights the importance of adhering to all NEC guidelines to prevent potential hazards associated with high voltage installations. This voltage level necessitates careful attention to detail and adherence to best practices to ensure a safe and reliable electrical system. This includes selecting appropriate equipment rated for the voltage, ensuring proper grounding and bonding, and implementing appropriate safety procedures for working with high voltage equipment. Ultimately, the goal is to protect people and property from the hazards associated with electricity. Finally, To drive home the importance of correct gutter sizing and NEC compliance, consider the potential consequences of non-compliance. These can range from minor inconveniences to serious safety hazards. Undersized gutters can lead to overheating, insulation damage, short circuits, and even fires. They can also make it difficult to perform maintenance and repairs, increasing the risk of electrical shock. In addition to the direct safety risks, non-compliance with the NEC can also result in fines, penalties, and legal liability. Electrical inspectors have the authority to shut down non-compliant installations until they are brought up to code. This can result in costly delays and disruptions. Furthermore, if a fire or other electrical incident occurs as a result of non-compliance, the responsible parties may be held liable for damages. Therefore, it is essential to prioritize NEC compliance in all electrical installations. By adhering to the code requirements, electrical contractors can help to protect people and property from electrical hazards and avoid the potential consequences of non-compliance. Let's emphasize the importance of properly trained and qualified personnel carrying out the electrical work. The NEC and other electrical codes are complex and require a thorough understanding of electrical theory, safety practices, and installation techniques. Improperly trained or unqualified personnel may make mistakes that can lead to serious safety hazards. Therefore, it is crucial to ensure that all electrical work is performed by licensed electricians or other qualified individuals who have the necessary knowledge and experience. These professionals have undergone rigorous training and have demonstrated their competence in electrical work. They are also familiar with the latest codes and standards. By hiring qualified professionals, building owners and managers can ensure that their electrical systems are installed and maintained safely and reliably. They can also reduce the risk of accidents, injuries, and property damage. In addition to hiring qualified professionals, it is also important to provide them with the necessary tools, equipment, and training to perform their work safely and effectively. This includes providing them with personal protective equipment, such as gloves, eye protection, and arc-rated clothing. It also includes providing them with regular training on safety procedures and best practices. By investing in the safety and training of electrical workers, building owners and managers can create a safer work environment and reduce the risk of accidents and injuries. This is not only the right thing to do from an ethical standpoint, but it is also good for business. Safer workplaces tend to be more productive and efficient. They also tend to have lower employee turnover rates. Ultimately, investing in safety is a win-win situation for everyone involved. Let's also discuss the role of electrical inspections in ensuring NEC compliance. Electrical inspections are an important part of the process of ensuring that electrical installations are safe and compliant with the NEC. The electrical inspectors are qualified professionals who are trained to identify potential hazards and code violations. They conduct inspections of electrical installations to ensure that they meet the requirements of the NEC and other applicable standards. If an inspector finds any violations, they will issue a notice of violation and require the responsible party to correct the problem. Electrical inspections help to ensure that electrical installations are safe and reliable. They also help to prevent electrical accidents and fires. Building owners and managers should always schedule electrical inspections on a regular basis to ensure that their electrical systems are up to code. Electrical inspections are typically required for new construction, renovations, and alterations to existing electrical systems. They may also be required periodically as part of a routine maintenance program. The frequency of electrical inspections will vary depending on the type of building and the local regulations. It is important to check with the local building department to determine the specific requirements for electrical inspections in your area. In addition to formal electrical inspections, it is also a good idea to conduct regular self-inspections of your electrical systems. This can help you to identify potential problems before they become serious hazards. You can also use self-inspections to ensure that your electrical systems are being properly maintained. When conducting self-inspections, be sure to look for signs of damage, wear, or corrosion. Also, check to make sure that all electrical equipment is properly grounded and that all safety devices are functioning correctly. If you find any problems, contact a qualified electrician to make the necessary repairs. Remember, electrical safety is everyone's responsibility. By working together, we can create safer environments for ourselves and for others.